You all ready to talk about it or no? They're ready to talk about it? Anybody think they got the critical points? Yeah, maybe? Okay, I'm assuming everyone's okay with the derivatives. Y'all like the way I did that? I mean, not do you like it, like, I mean, y'all okay with it? Like, you probably would have done this something. Any of you would have just like tried to stick with quotient rule or something here? You could have, but I don't know. I would have just brought those up, obviously. All right, so I'm assuming everyone's okay with all these partials. All right, now here, let's get some volunteers to explain how they would go about it. And if you're right, then I'll say yes. If you're wrong, then I'll hit you with the magic stick. Huh? Extra credit, yes. Get lashings. No. See, this is what it comes down to now. Now we're solving equations, and we've solved equations before, but I mean, now we've got two variables in there, so we just have to be careful. I just want to make sure you don't do anything incorrectly. So, any ideas? No one wants to get lashed? Solve this for x, or I'm sorry, for this for y, so bring that over. And then do what? Take that and plug that in for that y? You could do that. You could also solve this for x and plug that in. The reason why I'm not leaning that way is because that's going to get like very complex fractions involved. So I'm not leaning that way, but I agree you could. So that is okay. No lashings.
What I did was I started with that, with the one on the left, multiplied both sides by the denominator of that.
Okay.
And then took the 2 out.
Okay, so you cleared fractions.
Cleared that.
Okay. This is almost okay. Almost okay. You multiplied both sides by x cubed y squared. What if x is 0? What if y is 0?
Too bad, I guess. I don't know.
So remember a second ago? Remember a second ago?
That was division. Since we're not doing that, I mean, even if we get the common denominator right here, so you know.
That's all I want you to do. Do a common denominator instead.
What I was saying.
Yes.
So, yeah.
Okay. But let's not multiply both sides by the LCD. Let's just get a common denominator.
Right.
So over here, and this is the way I think I'm going to go because I will avoid some of the complexities I might get if I do it the other way. So I'm going to just look at this two fractions. I'm going to get a common denominator, so I'm going to multiply this bottom by x cubed y squared, x cubed y squared. Right? I can do that. And on the top, what would I get here? 2x to the 4th y squared. Then I'll have minus 2, the other numerator, all over the common denominator, which is now x cubed y squared equals 0, right? I can do the same thing on this one, right, if I wanted to. So what would happen if I get a common denominator here? I'd have 2 x squared y to the 4th minus 2 over x squared y cubed equals 0. Y'all agree with that? I just did this one mentally. I just multiplied top and bottom by x squared y cubed, slapped them together. Now, the only time that a fraction can ever be 0 is when? When the top is 0. Okay, don't ever forget that. The only time a fraction can ever be 0 is when the numerator is 0. So I can go ahead and look right now, when is this 0? So 2x to the 4th y squared minus 2 equals 0. And this one over here says 2x squared y to the 4th minus 2 equals 0, right? Now if I try and solve for x here, I could, right? I could solve for x here and then plug it back in over there. Or I could solve for x or y here and plug it in over here. So I'm still at that stage where I could do that. But I'm going to try something even a little more, risky. I don't know if it's risky. Just they're both equal to 0, right? So they're equal to each other, aren't they? If this has to be 0 and this has to be 0, then they have to be equal to each other. So why don't I just set them equal to each other? If I set this equal to this, and then What do you say we move everything to one side? 2's are gone. 0 over here. Here, 2x to the 4th y squared minus 2x squared y to the 4th, right? We still good? Let's divide out a 2. We can do that. GCF, what do they both have in common? What would I be left with here? Difference of squares? Okay. I have a total of 4 factors, although this is a repeated factor. X, I can set that to 0, that to 0, that to 0, that to 0, can't I? For this one, what's my solution? X must be 0, right? This one, set that to 0, you get y is 0. Set this to 0, you get x plus y is 0, so x must be negative y. Understand that one? Set this one equal to 0, x minus y must be 0, add y to both sides, x must be y. Did that get us anywhere? All right, I erased the partials, but they're right up there, aren't they? They're right up there. Let's look at this first one here. If x is 0, talk to me about y. About y. If x is 0, it's going to satisfy the first equation, right? Look at this first one. 0 here. Oh, wait, hold on. I'll have division by 0, won't I? That's no go. Do y'all see that? This can't happen then. Remember, that's division, isn't it? Okay, let me try this one. If y is 0, then what? Oh, same thing. Can't have that. All right, let me try this. What if x is equal to negative y? If x equals negative y, then let me rewrite the first equation. 2x minus 2x to the negative 3. But what's y? I'm rewriting this. That's negative x to the negative 2, right? That's my first partial. That must be equal to what, though? 0, right, for this whole thing to work? I have an equation that just has x in it. Can we solve this? Let's see if we can solve this. This is 2x minus 2 over x to what power? X to the 5th, right? When you take negative x and you square it, move it to the bottom and then square it, it's positive x squared. Then you have x cubed next to it. So this is x to the 5th equals 0. Put those together. 2x to the 6th minus 2 equals 0 over x to the 5th. I'm getting a common denominator again. Right, putting these two together. And that means the top has to be 0. And then x to the 6th must equal 1, right? So this is not the only way you could get this answer. I don't know. I mean, there could be other opportunities to get to the same thing. You should get x is plus or minus 1, though. Yes?
Don't we plug it in the second part?
It should satisfy the second one also. Yes. We don't need to. See, all we needed to do is use the condition, right? We said x had to be negative y, right? If x is negative y, then can we nail down what x is? Can we nail down what y is? We said if x is equal to negative y, then the conclusion is that x has to be 1 or negative 1. So let's say x is 1. What's y? The opposite, right? What if x is 1, a negative 1? Then y must be the opposite. Understand? Okay, that's if x was negative y. We also had one more thing, right? What if x was y? So let's do that one. What if x is y? Does it change any of this? If x is equal to positive y, does this change? No, because of the squaring. Nothing changes at all. So we get the same thing with the exception of what? When x is 1, y is 1. And when x is negative 1, y is negative 1. See, because now they match each other. They're not opposites. So I have 4 critical numbers. Do y'all see these? This one is not as trivial as the other one. Now, there could have been another way to get these answers algebraically. I just took you down a certain road just to show you like the types of things that are fair game. I mean, this is all fair algebra here. All right, so there they are. So what do we have to do for each of these? Compute D, right? Compute D. Let's compute D. So let's write down what D is. I think I'll write down D. It's fxx, it's this one. So it's 2 plus 6 over x to the 4th y squared times fyy, which is this one. 2 plus 6 over x squared y to the 4th minus fxy, which is this one. 4 over x cubed y cubed, but then squared. Let's do this one first. What's D1 negative 1? Fun stuff. Well, it's not. This isn't going to matter, right? 1 or negative 1 is not going to matter because we're going to square them or raise them to the 4th power. So this is just going to be 2 plus 6 over 1. So this is just going to be 8. This one's going to be 8. 8 times 8. So 8 minus over here. So it doesn't matter because we're going to square it, right? The sign of this. This is going to be a 1 down here, negative 1 actually, and then so 16? Minus 16? Positive number. We agree? So because it's positive, I need to now go back and look at this fxx thing. It was also positive. So what do we have here? Local min. The way you can remember if it's a min or a max, you just have to remember back from Cal 2, concave up, positive on the second derivative meant concave up, meant local min. Same thing applies for this. Once you get to the d being positive, this part is either up or down, so min or max, depending on that. And I have a min where? 1, negative 1, and then something, right? You have to plug that into the function? I'm not going to do that. You could do that yourself. All right, now I go d negative 1, 1. Is anything going to change? Nothing is going to change, right? Nothing at all? Another local min? 8 minus 16, greater than 0. This is greater than 0. Local min. In fact, are any of them going to change? They're all going to give you the same result, right? The z coordinate might be different, right? But we're going to have 4 local minimums. Right? 4 local minimums. They're all going to be the same? I said they might be, but they aren't? They're all 0?
Well, we're just switching the x and the y's. That's all we're doing.
Yeah, so they're all the same. All right, do I need to do the other 2?
Yes.
Okay. So that's it, right? Let's take a look at the picture. This has got a pretty cool graph to it. I don't know why, but this graph, notice along the x-axis, if you look at it from the side like this, there's like this infinite like hallway that you can go down, right? Down the x-axis. And what's happening is your function is becoming asymptotic as you go like approach 0 on y equals 0, right? Goes like that. And that's because in the original function, you had that division, that 1 over x squared y squared thing. You cannot ever let x be 0 or y be 0. So the entire x-axis and y-axis are off limits. And so you get that shape. Here are my mins. There's all 4 of them. You can see them if I turn this upside down. You see them underneath there? They're my local minimums. I don't know why, but this shape for some reason reminds me of, did you ever play that game when you were a kid with the paper thing? Yeah? Where you go like that? I don't know why, this has always made me think of that little game. Blue. Pick your favorite color. Blue. All right. All right, so that's the function. Let me see what else we got here. Okay. I need to cut out a little early today because of a slight commitment that I have. What I like to do is I like to offer that as a bonus question. All right? It's not a huge bonus question, like it's not going to be like worth 10 points on your final or anything, but just an exercise. But here's the catch. It's due tonight by midnight. And that means that you'll need to find a way to somehow get it to me electronically if you want bonus for it. You can turn it in physically. Yeah, you can scan it. Okay, you can take a picture and email it as an attachment, but do not text me a picture. I want this all to be done with emails through Canvas. All right? Does that sound fair? Say midnight. It's 11:59 p.m. tonight. All right? So the good news is that if you just look here, you should have what appears to be 2 local maxes and 2 local minimums. But there's something very profoundly complicated in this problem that I'm not quite sure if everyone's going to catch it. Now, I'm not necessarily going to count off if you don't catch it. But if you're able to catch some of there's some significant issues that come up here. If you're able to kind of deal with it and reason through it and somehow in your work show me that you dealt with the situation somehow, then that might increase the amount of bonus you have. But if you kind of accidentally skip over it and don't see it, then it's not going to kill you. You'll be able to still get the local maxes and mins, but you're either going to see it or you're not. All right? Okay? There you go. Have fun. Have a good rest of your day. When we come back next time, we'll pick up the second half of 11:7. I don't know if those answers are true.